Welcome to the Explainer. There's kind of this secret code that governs how numbers group up and sync together. And today, we're going to crack it. It's one of those things that once you see it, you start seeing it everywhere.
All right, let's just jump right in with a real-world puzzle. So you've got these three traffic lights, all on their own timers. It seems complicated, right? But I promise, by the end of this, you'll see how a couple of simple tools make this whole thing surprisingly easy to solve.
Okay, so to tackle puzzles like this, you need a special kind of number toolkit. And our very first tool, it's all about figuring out the absolute best way to share and group things up.
And it really all begins with this one basic idea, the factor. Think of factors as a number's DNA. They're all the numbers that can divide into it perfectly, with no remainder. They're the basic building blocks. Okay, so building on that, what if you have a bunch of different numbers and you want to find the single biggest building block that they all share? Well, that's it. That's the highest common factor, or HCF. It's the largest number that fits perfectly into all of them.
Now, here's the easiest way to remember this, for sure. Just think of HCF as the greatest sharer. Anytime you see a problem that's asking you to split different things into the biggest possible identical groups, a little bell should go off in your head that says HCF.
So how do we actually find this greatest sharer? Well, a really powerful way is to just smash each number down into its prime factors, like its most basic parts. Then you just look at what prime factors they all have in common, multiply those together, and boom, that's your HCF.
Okay, theory is one thing, but let's actually see our greatest sharer get its hands dirty with a classic grouping problem.
So check this out. We've got mango trees, apple trees, orange trees, and we have to plant them in rows. But here's the kicker. Every single row has to have the exact same number of trees, and we want to make those rows as big as possible to use the fewest number of rows.
So let's pause for a second. What kind of problem is this really? Are we trying to divide stuff up into equal piles, or are we waiting for a bunch of things to happen at the same time? The way the question is worded gives it all away. It's totally a sharing problem. We're sharing the trees into equal rows, and because the goal is the minimum number of rows, that means we have to pack the maximum number of trees into each one. We're looking for the greatest sharer. We need the HCF.
And the HCF of 21, 42, and 56 is 7. It just is. So that means every single row must have exactly 7 trees. It's a perfect example of how HCF just hands you the answer for making the largest possible equal groups. Problem solved.
But, our greatest sharer tool, it's no help with those traffic lights. That's not a sharing problem, it's a timing problem. And for that, we need to pull out the second tool from our kit. Say hello to the least common multiple, or LCM. Now with this one, instead of looking for the biggest number that divides into our numbers, we're looking for the smallest number that all of our numbers can divide into. We're looking forward in time, not backward into their factors.
And the perfect way to think about this one, call it the first meeting point. You got runners going around a track at different speeds, or bells that ring on different schedules, or, traffic lights on different timers. The LCM tells you the very first moment in the future that they will all sync up perfectly.
And here's a really handy way to figure it out, the common division method. So you just line up your numbers, right? 16, 24, 36, 54. Then you start dividing by a prime factor that goes into at least 2 of them. So we use 2. And you just keep doing that, working your way down until you can't go anymore. Then, to get the LCM, you just multiply all those numbers on the left and all the numbers left on the bottom. Easy.
All right, we have our shiny new tool. Let's get back to that street corner and finally sort out those traffic lights.
So let's look at this one more time. We've got these 3 different cycles, right? 48 seconds, 72 seconds, 108 seconds. We're not sharing anything here. We're just waiting for that one future moment when all 3 of those timers hit their mark at the exact same instant.
This is just a textbook timing problem. We're looking for that first meeting point, that first rendezvous, and that tells us, without a shadow of a doubt, that LCM is the tool for the job.
So we do the math. We find the LCM of 48, 72, and 108, and we get a single number, 432. What does that mean? It means that exactly 432 seconds after they all change together, they are destined to all change together again. And of course, 432 seconds, well, that's just 7 minutes and 12 seconds. So if the last time was at 8:20 sharp, the very next time they'll all sync up is at 8:27 and 12 seconds. And there you have it. That's the answer.
Not so bad when you had the right tool, huh?
Okay, let's do a quick wrap-up and see how this amazing little toolkit can be used for all sorts of other things.
So, here's the big takeaway. Let's lock this in. HCF is the greatest sharer. It's for grouping problems, and your answer will always be smaller than or equal to your starting numbers. LCM is the first meeting point. It's for timing problems, and your answer is always going to be bigger than or equal to your starting numbers.
And listen, this stuff isn't just for made-up word puzzles. These two tools are absolutely essential for so much math. You ever need to simplify a fraction? You're using HCF. Need to find a common denominator to add two fractions together? Yep, that's LCM. They are literally everywhere. So, knowing this really does give you a new lens to see all the hidden patterns in the world, everything from planning a party to scheduling your work. So the only real question left is, now that you know how to spot them, where are you going to see these ideas pop up first?